Alright, so here goes an attempt at pouring some molten copper. I've got it in that furnace right there, in a crucible. This is going to be super dicey. I've got goggles on. I'm going to pour it right here into this container. Let me get another heat-resistant glove here. I have one on my left hand. Let's get one on my right hand, and then let's pour. Let's turn this off first. Turn off. Okay. Oh, whoa! It's smoking green. There's a green fire. That's not good. Okay. That's gonna be molten zinc. That's a fume you really don't want to inhale. So we're just gonna put the lid back on. And, yeah. So that right there is the, molten, certain source of copper that you're not supposed to melt. Shit, that was really cool actually. So that's probably going to oxidize really fast. Let's poke it and see. Yeah, it's solid now. Alright. So, let's try to grab it here. Put it here on the anvil. And now I suppose that I'm going to grab it here and attempt to hammer it into a shape of sorts. You can hear it sizzling because it's really hot. That's not hammer. Alright, so, lesson learned. This stuff needs to be cast. Oh, that's so cool though. Look at that. That's the base of the metal. I'm probably just going to dunk it in the water here and hear it sizzle. Ready? Let's put the camera. And that's hot. Wow. It doesn't have a really high heat or anything, so give that 2 or 3 seconds, it'll be cold again. Yeah, so that was about, dare I say, oh, that smoke is really annoying me now. That was about 75 cents worth of pennies. That's really cool. I tried getting some nickels pretty hot. They don't melt. They're obviously an alloy of nickel and copper, about 25% nickel, 75% copper. The nickel in there greatly increases the melting point of this stuff. So I guess we're going to see. That's not hot at all. Look at that. So right here, it looks like a gas bubble formed and sort of, yeah, look, there's a little sliver of it. Huh. That is very cool. Yeah, so I think that's exactly where I poured and it sort of splashed out from there. It cooled off really quick though. It's because I was melting it with the crucible exposed to the air, so the top of the crucible was really cold. The bottom of the crucible was obviously very hot, so as it went up the crucible, it cooled off pretty quick. So, yeah, lesson learned. Basically, get a mold ready next time. That's something I'm gonna have to do. Now that I know I can actually pull this off, though, I'm definitely gonna make some molds. That is really cool. You can see it's tarnishing really fast though, so wow. I have never done this before. Very cool. Yeah, so that was like a $300 furnace, pretty cheap, low-end thing. Cheapest thing I could find on Amazon, really. I didn't want to use a gas one just because I'm obviously in a city here. Trimix is not the greatest idea anyway because those gases aren't really great for you. So what's nice about this though is this should fit back in that crucible, this piece here. So I can melt this down again and again and again. But yeah, very, very neat. I'm going to try hammering at this a little more, see if I can just bend it into shape here. So obviously this is well, I don't know. I guess it's mostly zinc, isn't it? This is going to be mostly zinc metal. There must have been, let's see, what is it? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, Zn. I think copper is actually lighter than zinc. So the copper must float on top. Can't look it up, my phone just died. I do have my laptop here. I think copper is lighter than zinc. I'm going to sound like a total idiot if I'm wrong. Periodic table here. Connect to the Wi-Fi. Let's see. Yeah, copper's directly below zinc, right after nickel on the table. So that means it's going to be lighter than zinc, which means that the small amount of copper on top of the pennies, or on the outside of the pennies, is going to float to the top of this solution. And it's going, I guess it'll help keep the zinc from oxidizing, but it shouldn't stop the zinc from boiling. Because I believe zinc's boiling temperature is, oh god, I want to say 1200 or 1300 Fahrenheit? Back to the table, I guess. Come on, why did I close the lid? Alright, let's see. Zinc. Boiling point. The boiling point, oh okay, 1665 Fahrenheit. Okay, so I actually wasn't hot enough to boil the zinc. I'm not sure what was smoking then. It was probably impurities, trapped, and burning. Either that or the zinc itself was burning after the copper layer was poured off, or maybe it was the other way around. That did look pretty green, so what we're going to do now is, now that this has spread a little more evenly / cooled off, I'm going to pour the rest of it on. Oh yeah, that was definitely zinc doing some funky stuff there. Yeah, there's nothing left to pour in that crucible. So we're just going to let it back in there. And I guess at this point, you know what? That's already open to the air. We're just going to let that cool all the way off with the door shut so I don't get sick. I will try to make another video on this later when I get a mold going. So, yep.